Right, let's start this with a diagram. I'm going to draw a small angle because it will help me to figure out things a bit later on. So we're looking at cyclists coming head on here. And then we're going to see what forces must be acting. There's a normal reaction force and the weight of the cyclist. And those are the only two forces, but when they add, they will make the resultant force, which is the centripetal force, which is what helps the bicycle to turn. Right now, so we're given the radius and the angle, and we need to find the speed. So the normal reaction is not going to help us, and we also need to do something with this angle. The way I drew my triangle with a small angle helps me to figure out that this must be the angle theta and not this one, which is quite big. It's a bit of a lazy way of doing it, but it seems to work. And now I can write down a little bit of trig. So ignoring n and using tan, I can say that tan theta is equal to the opposite, which is mv squared over r, divided by the adjacent, which is mg. Masses cancel. And then I'm left with tan theta equals v squared over gr. Rearrange that to get v squared as the subject, and v squared becomes gr tan theta. So I need to take the square root of that. Oh no. There we go. Right, so putting the numbers in there, I do 9.81 times the radius, which is 50, times the tan of 35. Take the square root, and that gives me, that gives me v equals to 18.5 meters per second.